Hi everyone, in this video I'm going to discuss a question from SAT Practice Exam 1 or rather Practice Test 1, and it's from the section 3 without calculators. So section 3 is without calculators, and as you can see this question is on an algebra topic whereby you simplify fraction equations, right? So it's just simply asking to just simplify this, right? They want you to simplify this. Okay, so in this question you don't need to worry too much about this x greater than 3 or all that stuff. It's just some logistical stuff, but for your answer it's just simplifying this algebraic expression, the fractions. Okay, so at first sight it may seem complicated, um, but let's just break this up into two components. The first component is the denominator here, right? So let's just break up this. The denominator itself is a fraction, and then we have this numerator, right? So the numerator is not that. I mean, it's simple as it can be, right? You can't. I mean, it's just one. So what the heavy part is about is on the denominator. So we'll just work out the denominator first, right? So we are going to work out the denominator first. So I'm just going to write out the denominator. So I'm going to write it out in two different colors for clarity. So I'm going to have x plus 2 over here, and then I have plus 1 over x plus 3. So just going to write it like this. So why do we so what's so what do we do now? So you can't just go ahead and add two fractions. You need to have the same denominator on the two fractions. So here you just have x plus 2, and then on the other side you have x plus 3. So you can't just go ahead and do anything with this. So we need to convert this fraction into these two fractions into something that has the common denominator. So sometimes people call the least common denominator, or you can just call it the common denominator itself, right? So how do you find the common denominator? Let's just write the two denominators. We have x plus 2, and then we have then x plus 3, right? So these are the two denominators that we have. Okay, so go to the first denominator, write out all the factors, x factors. So we have x plus 2. Anything else on the left hand side, the blue side? No. And on the right hand side we have x plus 3, right? So then just write this out. So this is just going to be the common denominator. Okay, fine. This is just, as you can see, it's just multiplying out the two different denominators. But this is not always the case. For at certain times, the denominator is not more. It's just something more than just multiplying out the two denominators. So I will be discussing few examples with a different type of approach. I mean, this approach is the same, but the result is going to be a little bit different, right? So we will, after working out this question, we'll go back to, I'll just discuss some examples by where you will understand that it's not exactly the same thing that we are going to do, just multiplying out the denominators, right? Okay, fine. Right, so we have this common denominator. So now back to the initial problem of solving, adding two fractions. So I'm just going to rewrite it down here, but with a common denominator. Okay, so the blue fraction, you have x plus 2 and x plus 3, right? And I'm just going to just start out writing the red fraction 2. So we have x plus 2, and then we have x plus 3, right? Okay, so somehow we will have to convert the blue fraction over on the top here into a fraction that has x plus 2 and x plus 3 as the denominator. So how do you do that? Well, the simple thing is that you need to do is you just multiply this by x plus 3, right? If you multiply the denominator by x plus 3, you see that it turns into this common denominator. But you can't just only multiply the denominator. You need to do this the same thing for the numerator as well. Okay, so fine, you just multiply this out by x plus 3. So what happens? The denominator changes into x plus 2 times x plus 3. On the numerator, you just multiply 1 by x plus 3. So you have x plus 3 over here. Okay, good. Right. So what about the red fraction? So to start out here, over here you have x plus 3. But down here you want to convert it into the common denominator, which is x plus 2 times x plus 3. So what you do is you basically multiply the denominator by x plus 2, and as we did earlier, you need to do this for the numerator as well. Okay, fine. So the denominator turns into the common denominator, which is x plus 2 times x plus 3. Okay, fine. The numerator is 1 times x plus 2. You have x plus 2 itself. Okay, right. So now the fraction is the two fractions are really nice. We have two matching denominators. Denominator on the blue fraction and the denominator on the red fraction are the same, right? Okay, so now we are good to add them together. So we can write the common denominator together, which is x plus 2 and x plus 3 over here. Now what happens with the numerators? You just add them together because you have x plus 3 plus x plus 2. Fine. Okay, so what happens here? We have x plus 3. If you just take out the parentheses, you have x plus 2. Then down below you have x plus 2 and x plus 3. Fine. Equals, so it's just a simple simplification of this algebraic expression, whereby you combine the like terms together. So x and x, this gives you 2x. 3 and 2, it gives you 5 plus 5. Okay, fine. Down below is just this common denominator, x plus 2, x plus 3. Okay, so this is what we end up with. So what have we done here? So we have simplified the denominator of the initial expression that we were dealing with, which is 1 plus x plus 1 over x plus 2 plus 1 over x plus 3. And this turns out to be, as you can see, we found out that it's just 2x plus 5 over x plus 2 times x plus 3. Good. So this is what we get. Okay, but this is not the answer that we are looking for, right? We are looking for this. If you remember, in the question we had 1 over 1 plus x plus 2 plus 1 over x plus 3. Okay, so what we do is we can just replace this whole thing by what we found out. So we still have the numerator 1, and so this is just 2x plus 5 and over x plus 2 and x plus 3. So we have 1 divided by a fraction. So we are basically dividing out 1 by this fraction here. So another way to deal with this type of fractions, what I would recommend is, okay, let's write it in a different way. 1 divided by 2x plus 5 over x plus 2, x plus 3. Right? So you're dividing 1 by this humongous fraction. We can write it in this form, right? 1 is divided by this humongous fraction. Okay, how do we do now? Right, so we have 1. We won't change that, but I'm going to change this division into a multiplication. You can do that, but you need to change something else, right? What do you change? We change this. How do you change? We take the reciprocal. So what you do is to just exchange or flip the numerator and the denominator. We have x plus 2, x plus 3. The numerator goes to the denominator goes to the numerator. So 2x plus 5. Okay, so now what do we do? This 1 over here is just like 1 over 1, right? Do you agree? It's just 1 over 1. It's the same fraction. you multiply the two numerators together, the two denominators get together, you just end up with x plus 2, x plus 3 over 2x plus 5. That's where you end up. Okay, so this is going to be your final answer. Let's just revisit the question that we were working with. So I'll just rewrite the thing that we got. We got x plus 2, x plus 3 over 2x plus 5. Okay, good. Okay, look at the answers. The only answer which has 2x plus 5 in the denominator is this, right? This b. So this should be your answer. The top is different, but you see why, right? So so what we are going to do is we're just going to distribute the numerator. So what happens when you distribute the numerator? We are going to get x times x, that's x squared, 2 times, sorry, should have done x first, so x times x squared, x times 3, 3x. You do this with 2 times x, which is 2x, 2 times 3, that's 6 over 2x plus 5. Okay, and then we get, you have x squared, you take the like terms together, which is 5x plus 6 over 2x plus 5. Good. So this is what you get at the end of the day. So you see that they match together. So in the interest of the exam, you may stop here and then straight away realize that 2x plus 5 should be in the denominator and then just choose B, right? But for the sakeness of completeness of this question, I moved until this until the final answer. So yeah, so that's the end of the question, the end of the answer for this question. Okay, right. So I would like to discuss some more questions that are similar to this, so that you get a good understanding of how to deal with these questions. Okay, let's move on. Right. Okay, so another example, let me give you. Let's say you want to add these two fractions. You have 1 over, 1 over x plus 1, and then x minus 2 plus 2 over x plus 1 and x plus 3, right? Okay, now if you want to deal with that, this is how you can do, right? So first we find the common denominator. So okay, let's do this. So what are the two denominators we have? We have x plus 1 and x minus 2, and then we have x plus 1 and x plus 3. Good. So we put all the factors together. So in the first denominator over here, we have x plus 1, fine. And we also have x minus 2, okay. But on the right hand side, we also again have x plus 1. You're not going to duplicate any of these x plus 1s. Just if we have x plus 1 already in our common denominator, just leave that out. And then look at this one. This is x plus 3. So that's a new factor for into our into this thing. We have x plus 3. So this is what it is. So it's not merely just multiplying out the two denominators. If we had done that, you would have an x to the 2 here, because you have an x plus 1 and x plus 1. So it's a little bit subtle. You just take all the denominators together. Okay, fine. Right. So we have this common denominator. I'll just, as earlier, I will just write maybe, yeah, just write it down over here. X plus 1, x minus 2, and x plus 3. Okay, so this is not 1. We need to fill out the numerator, and on the other side also we have x plus 1, x minus 2, and x plus 3. Okay, fine. So now let's look at what to multiply the first fraction by to get this. So what is missing is x plus 3, right, from the first fraction. So we need to multiply the numerator and the denominator by x plus 3. So we end up multiplying 1 times x plus 3, right? Okay, so going back to the next fraction, we have 2 here. So that means we have 2 times x minus 2, which is the missing factor from the denominator in the first fraction. Alright, so let's see what we can do now. So the first fraction is just x plus 3 plus, so I'm just going to combine everything together, 2x minus 2 over x plus 1 x minus 2 times x plus 3. Okay, good. Okay, now we need to put them together. I mean, simplify the numerator. So x plus 3 is just as it is. Now we just distribute this. 2 times x is 2x. 2 times negative 2 is negative 4. So we have x plus 1, x minus 2, and x plus 3. Good. Okay, fine. So what do we have? So we put the like terms together, which is just 3x. X plus 2x is 3x. 3 minus 4, which is negative 1. Okay, so we end up having x plus 1, x minus 2, and x plus 3. So this should be a final answer. Okay, good. Right. Okay, let's do another example. Okay, so the other example is, okay, we have 3 over x minus 1 squared and x minus 2 squared, sorry, just x minus 2 minus 5 over x minus 2 cubed x minus 3. Okay, fine. This seems a little bit complicated than what we have seen earlier. Okay, so let's see how we can work this out. Okay, right. I mean, I'll just drop this term here because I don't want this to be too complicated if it's to be. So let's just have x minus 2 to the 3, right? We just want, this is just an stuff. So, okay, so we have this, let's see. So we need to find the common denominator. Okay, so to start with, we have x minus 1 squared and then x minus 2, and then we have x minus 2 to the 3, right? Okay, fine. So okay, so let's look at all the factors. I mean, for the moment, just forget about the the powers on these factors. Just write out the factors. So we have x minus 1, and then we have x minus 2, right? Okay, good. And anything new, any new factor on the right hand side? No, x minus 2 is already over here. Okay, now let's look at the powers of each of them, right? So x minus 1 has 2 and we don't have any x minus 1 factors on the right hand side. So the power of this will be just 2. Okay. And on the for x minus 2, so the first denominator has an x minus 2, but on the second denominator it's just it's power to the 3, right? It's you have third power. So just so you pick that because this is just power to the power 1, right? Just writing x minus 2 is just x minus 2 to the power 1. Okay, so we have the maximum power is 3, so we pick the maximum power. So you see what you do when you want to find a common denominator, write the two or three two denominators and then pick all the factors, different factors that you have in both denominators, and pick the highest power that you can assign for the denominators based on, based on the two denominators, right? So since you have x minus 1 here to the power 2, you just add 2 here, and x minus 2 for x minus 2, you have power 1 versus power 3. So you just choose power 3. Okay, good. All right, so now we have to write the this fraction in the common denominator, with the common denominator. Okay, the first fraction, we have x minus 1 squared, x minus 2 to the 3. The second fraction also we write it the same denominator, which is x minus 1 squared and x minus 2 to the 3. Good. Oh, this should have been 5 minus here. Sorry. Okay. So how do we do this? So look at what we need to change here. So to change this denominator into this denominator, so x minus 1 to the 2 is already there, right? The only thing that is missing is we are missing a power 2 of x minus 2. So you need to multiply the numerator and the denominator by x minus 2 squared. 3 times x minus 2 squared. Okay, so that's what you do here. 3 times, so because what is missing is a factor of x minus 2 squared. So you multiply both sides by x minus 2 squared, x minus 2 squared. So that's how you end up with this. Okay, it's just a matter of turning the denominator into the common denominator. Fine. Okay, so going to the other fraction, we already have x minus 2 to the 3 in this fraction. What is missing is x minus 1 to the 2, right? So we just multiply both sides, top and the bottom, by x minus 1 to the 2, x minus 1 to the 2. So we have 5 times x minus 1 to the 2. Okay, good. Alright, so we are good now. So we just put all this fraction together. 3x minus 2 squared minus 5 times x minus 1 squared over x minus 1 squared x minus 2 to the cube 3. Okay, fine. Now we need to simplify the numerator. So 3. So we just keep 3 and then we need to actually take the second power. Okay, so how do you take the second power? Let me write this formula. I hope you know this, but I'm just rewriting it again. So let's say you want to have a plus b, you want to have the second power. So the formula says that this is a squared plus 2ab plus b squared. Let's say if you have a minus b squared, it says that a squared minus 2ab plus b squared, right? So this is the formula. So I hope you have seen this earlier and you know this, but I just wanted to mention this in case if this is that familiar to you. I just recommend you get familiar with this. So we have x minus 2 squared. So x is like a and 2 is like b in this situation, right? So this is going to be x squared minus 2ab, which means this is going to be minus 4x squared b squared plus b squared, which is plus 2 squared, which is 4. Now we have 5 times, or let me write it in the next rule so that it's much more clear. 3 we have as you see x squared, and then we have negative 4x because this is 2 times ab, which is 2 times x times 2, which is 4x, minus 4x we have, and plus 2 squared, which is 4, minus 5 times x minus 1 squared. So that again you apply the same rule, we get x squared minus 2x plus 1. Fine. Okay, so we have the denominator that's already there. You're not going to change anything, you can just keep it like this, right? Don't need to distribute any of this, it's going to be a mess. Alright, so we can just distribute this, we get 3x squared minus 12x plus 12, and once you distribute this, so you remember that, make note that there's a negative sign here, so you're going to distribute negative 5, not just 5. So when you distribute inside negative 5, you get negative 5x squared plus 10x, because negative 5 times negative 2 is just going to be positive 10, and then you have x, and negative 5 times positive 1 is negative 5. Okay, x minus 1 squared, x minus 2 to the 3. Fine. Okay, so again we do the like term. So we have 3x squared negative 5x squared. This gives you negative 2x squared. Negative 12x plus 10x, this gives you negative 2x. 12 and you have negative 5, this gives you positive 7. And this is what you get, x minus 1 squared, x minus 2 to the 3. Right, so this is your final answer, right? You have simplified this. I mean, this is a heavy compute. I mean, I don't say it's a heavy computation, but it's so many steps. But if you get used to this fraction, adding fractions and all that, I mean, do a few more examples. I think you get when you once you get the hang of it, you may be able to do this with much more less steps than we did here. And yeah, so I hope you gain some important knowledge from this. So hope to see you in another video. So have a nice day.